Hello, welcome everyone. I'm Grzegorz, and you are pronouncing my name really properly. If you really prefer, I may be Greg for you. I'm doing mostly research around Windows. I'm working every day in a large organization trying to implement AppLocker, so I started to dig into AppLocker, finding a lot of interesting things. When it comes to AppLocker, what AppLocker is, kind of a short introduction for you. It is one of 3 ways we have within Windows for application whitelisting. Because the typical approach we have built into Windows systems, we are using every day on our desktops just by default, it is we have kind of an anti-malware, antivirus, however we call it, trying to block malicious actions, especially trying to block you from running well-known malware. So if you download the malware to your machine, try to run it, probably something will pop up saying it is not allowed to be run. It is the typical blacklisting approach, telling you it is not allowed because we know it is bad. Whitelisting approach is totally different. It is different paradigm, telling you you can run only what you have allowed previously. And in Windows, we have 3 ways of doing this. The very first, historically saying, is SRP, Software Restriction Policies, being built into Windows XP. SRP is not the smartest thing because it relies on the Explorer, and the Explorer is your process, so you can manipulate the process trying to enforce you from running unwanted processes, so it is not that effective in practice. It's easily hacked. By the way, one of the most known applications being used for bypassing SRP is a tiny program called GP Disable, written by Mark Russinovich. After Mark Russinovich joined Microsoft, this program magically disappeared from the internet. You cannot find it anyway. Right now, we have 2 possibilities. It is AppLocker, being built into Windows, starting from Windows 7, if I'm right. And we have Windows Defender Application Control. They're working, I can say, in parallel on different levels. AppLocker is definitely more user-friendly when you have to manage it. WDAC is protecting you better, but the overall landscape is not only about the technical possibilities of the solution, but about friendliness, the knowledge of administrators and so on, the whole landscape. I'm more pro-AppLocker, I would say, even if WDAC is better when it comes to the pure technology. When it comes to AppLocker, we have a couple of components working within AppLocker. So we have a management console, absolutely absent in WDAC, by the way. We have a graphical interface, I will show you in a moment. We have some PowerShell. We have some special service. The service must be run to have your whitelisting working, which is AppID SVC. We have some kernel driver doing some magic with tokens, for example, and we have a login component. And right now, I can show you a couple of things when it comes to AppLocker. Not yet about the hash, but we are going closer. Here I can see the AppLocker log. I can see a couple of entries. I will return to them in a moment. When it comes to the management, there is a segpol.msc console when you can define under security setting, application control policies, and AppLocker. For the AppLocker, you define what you are trying to do on different levels, because you can perform whitelisting on executable files, on Windows installer MSI files, scripts, and appx files. Actually, .exe, typical executables are the most common and reasonable. It would be great to include DLLs here as well. You have to enable it on this page to enforce DLLs as well. For every single category, you have a possibility to pick the right way of protecting your machines. Because we can work in 2 modes, in the audit mode and the enforcement mode. In the enforcement mode, if something is not allowed, it will simply not run. There will be a default kind of a message telling your user it is not allowed, your user. When we work in the audit-only mode, everything is allowed to be run, but we can see what we see over here, for example, for this warning. If I see it. I can see there was something in temp. This host, some automated stuff being done within Windows, not being whitelisted. And I have warning because it was allowed to be run, but if we play seriously, it would be blocked. Okay, so I have two rules defined over here. Just for demonstration purposes, the first rule is based on a path. If something is within C program files, then it's allowed to be run. The second rule is if something is within C Windows, it is allowed to be run. Because a regular user cannot drop, in most cases, let's say, an executable file there. So if a file is within one of those paths, it means an admin did it. So it is legitimate by the location, I would say automatically, because it stays here. So I do not have to manage hundreds or even thousands of different executable files because I have created those two rules for paths and it is perfectly enough. So if I run something, let's say from my desktop, okay, it's the wrong console. This is the right one. There I have an application called Write AAA, writing 100 A letters. You will show in a moment why. This application is run from my desktop, which is obviously not program files and not Windows. So if I do F5, I can see a warning. It would be blocked if you play seriously. AppLocker detected it and warned us. Okay, so you can see AppLocker is trying to register every single executable file being run, but there are some interesting cases over here. Because I have written a tiny DLL file. Actually, DLL files can contain the same type of executable code as we have within .exe files, but we have no DLL rules being defined here. So I will load my DLL. If I do dir, you can see there is my DLL called ignore applocker.dll, and I will load it using run DLL32. Run DLL32, ignore applocker.dll, the method is called doit. C Windows system32 cmd.exe, and new CMD appeared. It is very special CMD because if I do whoami/all, I will see I'm acting here as a system. Actually, this DLL is stealing the token from one of the services and is launching a new process, I have specified in the path over here, on the stolen token. So I have a stolen token from system, and what is most important over here, the token stolen from the service contains within its data a very special seed, telling clearly it is a service. It is a seed S156. If AppLocker sees such seed in the token, it totally ignores such process. So I run DLL32 as a regular user. CMD was launched as my special service user on a special stolen token. Whoami.exe, also an application, was launched on this token as well. If I launch something from my desktop, which is clearly not allowed, let's go here, and I will pick one of the applications. Right, AA is not a bad example. Shift right click, copy as path. Now I can paste, Control V. It was run. Not a big surprise. I am here in the audit mode, but when I look into the event log, I can see the last thing here is run DLL was allowed to be run. This is right AAA, but from my previous run. This one is the freshest one. It is 306. It is the moment I have run DLL running. Everything happening next from my second window was totally absent in the AppLocker log, it would be totally absent if AppLocker really enforces me and trying to block some application. So if S156 appears within the process token, such process is totally ignored by AppLocker. There is one thing more, but it is documented, so it's not that funny. Because if you have API function create restriction token, under parameters you have a sandbox inert parameter saying clearly, control scroll, saying clearly it will be ignored by AppLocker. This flag disables checks for AppLocker. But it's not that funny because it's documented. And the previous one is not documented at all. So we can bypass AppLocker by manipulating the token. It is the first case. Okay. When you create rules for AppLocker, you have actually three possibilities. I will go here. This is the console I need. Create a new rule. And you have three possibilities for creating a rule. First, through the wizard, you have to specify this allow or deny. Please do not create deny rules. AppLocker is about allowing, so deny rules are pointless. Here we can specify a user, which is a great advantage of AppLocker over WDAC, because we can specify the special group. This group is allowed to run everything, and if we put a user into the group, this user magically can run anything. If you remove a user from this group, of course, after creating new token, which requires log off, log on, and so on, but we can manage easily who can run everything. Anyway, when you create a rule, you have three possibilities. We can rely on digital signatures, publisher here. We can rely on path. It is what I did for program files and Windows. And we can rely on a file hash. For a file hash, I will browse files. I will pick my write AAA, my simple application, write AAA, open, create, and now I have a rule based on a hash of this write AAA file. So if the hash of the file matches, executable file is allowed to be run. If it does not match, it will be not allowed, at least not by this rule. If I right now, I will close this console as this one is ignored anyway. If I right now, I will run write AAA again, within the event log, not a big surprise, I will see write AAA was allowed to be run due to a rule specifying its hash. So, what I will do right now, I cannot easily plug in and plug out an external drive into my virtual machine, but I can create a VHD file and detach and attach it, allowing me to manipulate the data on the drive in a physical way. So I will attach a VHD file to my VM, ctemp x vhdx, x drive will appear. I will copy write AAA into X drive. I will run it X write AAA. It will run as everything runs here. In the event log, not a big surprise, X write AAA was allowed to run as the hash is the hash perfectly well allowed by the AppLocker. So, what I will do right now, I will detach the drive, detach VHD. Yep, I want to detach it. I will open it with Hex Editor, which I have on the desktop, which is yet another one application to be allowed, by the way. I will open it, X VHDX, Control F, AAA. Oh, does not matter, but you can see it. It is here. This is probably at least some of you did in the past, hacking applications to display your name instead of the legitimate developer name if you run an application. It's exactly the same level of advancedness I'm doing here. I will replace a couple of A letters with dots. Now I will save it. I will close it. And I will attach it again. Action, attach VHD, ctemp x vhdx, The X drive appeared. I'm here. X write AAA, not a big surprise. You can see those dots I have manipulated on the physical level on the drive. But was it allowed to be run or not? From the security perspective, the answer should be really simple. It should be never allowed to be run. F5, from the AppLocker perspective, it was allowed to be run. This warning is about my hex editor, just to let you know. But the write AAA, the manipulated one, was perfectly well allowed. So, let's try to figure out what is going over here. So, I will run PowerShell. PowerShell double L will work better. Get file hash for my write AAA on the desktop. It is D355 at the beginning, SHA-256. Get file hash X write AAA. Totally different. Not a big surprise. I have manipulated the file, so it must be different. But AppLocker allowed it. So what is the AppLocker policy? Get AppLocker policy local. I will put it this way, and to XML. This is the AppLocker policy, and here you can see the information within the AppLocker policy, the rule. And as you can hopefully see, the hash is yet another different. It's not this one, not this one. All those three are SHA-256, but they are totally different ones. So what is going on here? The very first thing when it comes to hashes is AppLocker is saying is SHA-256, but is lying. It is not SHA-256. It is not clearly documented what AppLocker is using here, but if we dig deeper, we can realize the hash matches so-called authenticode hash. There is a well-documented algorithm invented probably by Microsoft, if I'm right, for creating hashes for executable files. It is commonly used for digital signatures in practice. And AppLocker is using it here, not telling you it is using it. It is lying, it is SHA-256, which is not the truth at all. There is an undocumented algorithm here. You can specify SHA-256 flat as an algorithm. There is no single mention in the documentation about this. And then you can use SHA-256, the real SHA-256. Anyway, AppLocker is telling you something else about hashes, but still, the hash for this file I have manipulated must be different. So again, what is going on? Here I will use, I will launch console as an admin. I will use a built-in fsutil command. Fsutil is one of my favorite commands in Windows. It is a command being constantly managed and updated by the team responsible for the file system, for the NTFS file system. So if you can do some magic with NTFS file system, fsutil probably is the right tool. Fsutil file query AA is querying for extended attributes. Files within NTFS file system can have so-called extended attributes. You can think about extended attributes like if you are familiar with alternate data streams, extended attributes are kind of like alternate data streams on steroids. They are slightly different, but the purpose is somehow similar. So there is kind of a metadata you can attach to any single file within the file system. It may have some name, it may be different length. It is just a metadata kind of an attribute to a file called AA, which means extended attribute. If I display the extended attribute for my write AAA file, I can see those are extended attributes of my write AAA. And here, the last one, the long one, is not that interesting in this case, but this one is very interesting. It is called $kernel purge app ID hash info, and you can see, if you look close, this 6E38 and so on is exactly here. It is the same piece of the data. It is the hash of the file, the AppLocker version of the hash, being stored as an external attribute, extended attribute of a file. And how AppLocker works? AppLocker does not calculate the hash every single file run. It would be time consuming. It would be too expensive in terms of computation, storage, operation, etc., etc. So at the first run, this extended attribute is created. It contains the AppLocker hash of the file. And during next runs, only the cached hash is being verified. What does it mean? If I manipulate the file on the hardware level, which I did using hex editor on my VHDX file, the hash is not being updated. And AppLocker still relies on the hash, even if the hash does not actually match the file. So I can manipulate the hash, and AppLocker believes it's cache instead of real file content. When it comes to such extended attributes, again, some documentation exists. It is here about kernel extended attributes. About two interesting things here. I will scroll a bit to find the information which I want to show you. It's about $kernel.purge. Actually, if the extended attribute name starts with the $kernel, it is a kind of a flag for the NTFS driver. Only kernel code can create such extended attribute. So I cannot create a $kernel something something on my own if my code is running in the user mode and not in the kernel mode. .purge means if the file is being touched, exactly saying any of those operations is being performed, then an entire attribute must be removed automatically by NTFS driver. It is why the hash is good enough if I manipulate the file the standard way. But if I manipulate the drive, which is plugged off of my machine, there is no way NTFS driver will realize what I'm actually doing. So it is how it is working. So AppLocker relies on this hash, and if we are smart enough, digging deeply enough in the structure, we can manipulate the data without being noticed by the NTFS.sys driver, so the attribute is not being automatically removed. If I edit this file traditional way, of course, this extended attribute will disappear, and during next run, AppLocker will recalculate the hash from the new file, maybe the same one, but it will recalculate it, and it will put it into the extended attribute. There is interesting thing over here, because there is a clear proof that AppLocker trying to allow or disallow a .exe file from being run relies on its cache on its hash being cached. But we have also a special command called test AppLocker policy, which is a commandlet in the PowerShell, asking AppLocker what AppLocker would say about this file if we try it to run. I will put this XML file into a file, let's call it xml.txt, out file, xml.txt. So now I have my AppLocker policy saved into a txt file, because the next command, the command test AppLocker policy, requires a file to be specified. Test AppLocker policy requires XML policy to be specified, so it is test XML.txt, thank you. And it requires another parameter, which is path. Let's say it is about write AAA here. And on the legitimate file, it will say it is allowed. It is policy decision allowed, because we have a matching rule called write AAA. This is the name of the rule as well. So it is saying, based on this rule, we will allow this file to be run. If I do the same on the X drive, and my manipulated content, you will see it will be denied by default. Because AppLocker relies on the cache, and test AppLocker policy command relies on the real file content, just to make it consistent and look more Microsoftish way. So, please be aware that such manipulations are possible only if you have a physical access to the drive, because it's not something end user can do easily. Even attaching, detaching VHD file is not something allowed for the end user easily, because it requires some privileges a typical user does not have. But when it comes to the USB drive being plugged out and plugged in, then we are on the good side and we can try to manipulate it. Maybe hashes and such manipulations are not that common, but we are still on the right path, I would say. Instead of manipulating the file content, which has a very limited practical applications, but clearly proving my idea, we can write an attribute to an existing file. So, I will exit from PowerShell. I will run my pawning applications. It is working. If I go for AppLocker policy, F5, you can see this application was detected as unwanted. Right now it is allowed to be run, but if you place a RUSI, it would not. So, if I know I have some hash-based rule, I can try to play with this as well. So I will copy it to the X drive, as manipulation on the X drive are easier. Copy my X drive. Pawning application was round, but it would not be allowed to run if we play seriously, which is clearly stated. XPWN was allowed, but would have been prevented from running. And I know I have my hash being prepared, and within my policy, I will copy the hash from here. It is the easiest place to take the hash in its editable form. I can try to create an extended attribute on a file which already exists, my XPWN. I cannot create what Microsoft documentation says. I cannot create $kernel something something. But I will do a dirty trick over here. I will create an attribute called hash kernel something something, and then I will rename it offline, which will be easier. So, here I have my set AppLocker hash cache application, set AppLocker hash cache. It requires a file name and the hash. So it is set AppLocker x pwn, and the hash I have just copied. On my X drive, it already has, so I will del X pwn, and I will copy pwn from the desktop to the X drive. My application is protecting, not allowing you to create a hash, the extended attribute which already exists. To the X drive right now, it does not have the extended attribute. I can clearly prove it by fsutil file query xpwn, no extended attributes. So I will do a command line magic. Watch carefully, F7, and I will use a history. And now it was planted over here with the name $kernel, which I need to change, hash kernel I need to change to $kernel. I will do this offline by detaching VHD drive, yes, by running my hex editor, again on the same file, Control-H or Control-R? Control-R. Search for $kernel.purge dot into the hash, for hash, changing to $kernel.purge dot, replace all, couple of occurrences will be replaced, okay, save, and close and attach a file again. Action attach VHD. But the first one was hash kernel, the second one was $kernel. C temp x vhdx will be attached. And right now, if I do the same command I used a moment ago for displaying, we had no extended attributes after fsutil file query A. We had no extended attributes. Right now, F7 and fsutil and so on, I have it added by my application and then renamed to $kernel purge app ID hash info by my physical drive data manipulation by raw disk access. So if I run xpwn right now, it is running, but the true will stick out from the event log. It was allowed to be run as AppLocker relies on its hash. So I can plant a cache of the hash on an existing file if I want. However, I cannot directly name it $kernel. It is not allowed by user mode, and I'm running my applications from the user mode, obviously. When I have a possibility to manipulate on the offline drive, probably yes.
No, I mean, is there any restrictions there, probably some blocks being passed or something, or you can do the restaurant if you want and you can create
If I'm creating an extended attribute using ntfs.sys driver, $kernel prefix is not allowed. If I'm manipulating the data offline under ntfs.sys driver, there is no such restriction. I hope it answers your question. So I can plant a fake cache information on an existing file. I have also I can also copy an existing set of extended attributes from one file to another one. I have a tiny application, copy AAs. I can specify source file and the destination file, and I will simply copy everything. So I can plant a hash cache, or I can copy everything. Because if I do, let's see, CMD should be a great example. FSU till file query AA C Windows system32 cmd.exe. You can see this is a different one. I will show it on the write AAA, as my write AAA application is digitally signed. I'm used to sign my applications, so the same command, but not on the C Windows, which is a slightly different way managed when it comes to the signatures. Write AAA, you can see there is a lot of information. The first one, AID1, is about the hash cache. The second one here, it is clearly called signer info. It is identified by AID3, and it is a cached information of the digital signature being planned on this file. So theoretically, you can also play with digital signatures hash, as digital signature is not verified every single file run. It is also being used from the cache. So we have some possibility to manipulate this. Typically, I hear two very common questions, two very reasonable questions when it comes to such dirty place with AppLocker hash cache. The first one, can we manipulate it the same way, not on the file image, but on the CD image? The answer is no. because on the CD image we have CDFS file system and not NTFS file system. It is totally different file system, so we cannot do this, which is great news for defenders, as a regular user cannot mount a VHD file, can plug in the physical drive if it's allowed by policies, but typical user can mount .iso file with the CD image, but it will not work for the ISO files. Another question I hear sometimes is about WDC, Windows Defender Application Control. What about WDC? And the answer is WDAC relies on such cache as well. Of course, those attributes are named slightly differently, but at the same time, WDAC does not want to use cache from the external drives. It relies only on the cached information from the system drive. So you cannot plug in the falsified drive. You have to plug out the C drive, manipulate it offline or by running from some bootable USB, whatever, and then WDC will rely on this information properly. So it is theoretically possible. At the same time, if you can manipulate the drive content offline for the C drive, you own this system anyway. You can do anything you want. So manipulating the cache for the something to have one application allowed to be run is definitely overkill if you can do anything if you have an offline access. Okay. When it comes to Shift 5 resources, I used to share my source code for those applications, my research, etc. This QR code, if you really want, is just this set of links being provided in a form you can use on your phone, on your device, instead of typing in, especially the last link is type in friendly. So you have them handy if you want. You can also scan my screen later on. When it comes to AppLocker, I try to show you its imperfections, and it is how I call it. It's about imperfections. Is AppLocker worth using? Yes, definitely yes. It really raises the bar for bad guys. Even if it's not 100% effective, it is still raising the bar. So you have a huge advantage using it. The good news, and it is a kind of fresh news, is like 2 months old. So comparing to the history of AppLocker is really new. AppLocker, starting this February, if I'm right, is allowed to be run on Windows 10 Pro. Previously, it was allowed to be run only on Windows 10 Enterprise and on servers, which clearly limits its potential in practical scenarios. Right now, you can launch and manage AppLocker in Windows Pro as well. When it comes to performance, well, you will clearly see it is not affecting performance if you run it in the audit mode, so you can turn audit mode literally today and observe what will happen in your log for the AppLocker, and then try to narrow down rules to allow what you want to allow, and then switch it to the enforcement mode and raise the bar for bad guys and make your systems better protected. That's basically it. Thank you very much.
Thank you, Greg. That was awesome. Great presentation. Thank you.
Thank you.
Does anybody have any question, comments, remarks that they would like to make?
Okay, so since the user can mount an ISO image, you can theoretically do the same thing to the ISO image, right?
ISO image uses different file system. It's using CDFS, which does not have extended attributes.
Oh, okay.
So it is impossible to be done with ISO image.
Is this possible using, say, an USB?
Yes.
Yes.
When you format USB to NTFS and manipulate it this way, it is possible for USB. Yet another reason to block unwanted USB devices.
Yes. So you can still send them, if you have the hash, you can send them USB, they will run it from the USB and they will be able to bypass the AppLocker, right? Theoretically?
Yep, I can imagine this.
Okay, thanks.
Welcome.
Any other question? Going once, going twice.
Okay, great speech. I have just a quick question. Most of us IT security guys know that AppLocker can be run as a local user. So what are the exceptions in this case? If we have configured AppLocker from the admin permissions or admin sites, so what can be done using local user permission in this case?
Well, if you are a local user, bypassing AppLocker will be not that easy if system is up to date and fully patched. In the past, we had like sandbox inert flag, which could be used by end user in the past, but right now you cannot steal the token from the service, which I did. It requires admin permissions, particularly as a debug privilege on the within the token of the attacker. So you must be an admin already. For end user, you can try to download potentially malicious DLL if DLLs are not whitelisted, because DLL can contain the same maliciousness of the code as executable file. And trust me, even if companies are implementing AppLocker, they are leaving DLL whitelisting for the next stage in the future. This is how they do this. So if you are a bad guy, put your stuff into DLL and then run your DLL using kind of a side loader for DLL, starting from run DLL 32, which is perfectly allowed, reg SRV or some other system applications loading arbitrary DLLs, and put your code into DLL. It is what I would advise to bad guys. But well, if you observe this closely, probably you will realize something wrong is going on. And at the same time, still it is well worth implementing AppLocker because you're raising the bar, even if it's not 100% successful.
Thank you.
Any other question? Greg, dziękuję. Thank you.